All right, welcome back. So here we are, 5.8. Now, in this one, they're telling us that they've already copied a version over for us. So it doesn't tell us we've got anything missing. So array sorted bag, uh, let's play it by ear and see what it is that they're looking to do. They want us to go into the array sorted bag file. There we go. Modify the add method to insert new items in the proper places. Finish the implementation of the new defined contains method. So they've got this contains method. Now let me back up. Let me reset this in case I've got anything from when I did it previously. I'm going to start working on something that's already been done. So here we go, we're all fresh. This should be nothing there that's new. So we've got the basics. Yep, this is all standard. The add, we're talking about a bag, so nothing unique. Clone, yep. Equivalent, count, contains is what we're going to have to work on. And down here we've got to take care of this add method. Alright, so in this add method, what's the difference logically between an array bag and array sorted bag? The word sorted. One array is sorted, the other one's not. So since this one, we're assuming we want it to maintain this sorted order if we add something in. There's some assumptions we have to take. One, it's already sorted. It's a sorted array. And a sorted array bag, if you will. So it's sorted. And since it's sorted, if I add something to it, I want what I add to it to be sorted as well, in a sorted position. So with that said, this does not take that into account. What are we doing here? Well, we check the array memory to see if we had enough space. Well, we got to do that anyway. So this part will remain the same. We're good there. But we've got some other stuff down here that we've got to deal with. Scroll up and hoping I can make that a little bit bigger for you, but we're fine. So I want to see, are we dealing with an array bag that's empty? Or are we dealing with, we're going at the beginning or the end? That's what I'm getting at. Are we dealing with the beginning or the end of the array? If it's sorted, I can go do two quick, and let's talk about this in terms of time complexity, because I want to be minimalistic when it comes to time complexity. Try to be efficient when I can. So in this step, I want to look to see what I'm putting in there. I want it to be sorted, but if I don't have to go through and do a search, man, that'd make things a little easier, wouldn't it? So let me look to see if what I'm going to add to my sorted array goes at the beginning or the end. Those are two quick and easy constant time operations. All right. So let's do that first. And all we're going to do is we're going to say if self dot is empty. So if is this thing empty? There's nothing there. Or item is greater than equal to self dot items len self greater to or equal to what's at the end. We need that -1 because we're talking about programming. Are we going at the beginning or are we going at the end? If we are, that makes it easy, right? Self.items and it's going to be len self len self equals item, and then I'll go ahead and I'll increase its size plus equals 1. So that if there's nothing there or we're going at the end, we just insert it. We're good. Now, what's the else? The else is that it's not going at the end, which means it's not empty and it's not greater than the last one, greater than equal to the last one. So now let's do an else. Now is when we have to get a little complex when it comes to time. And we're doing that same logic that we've done before. Find out where it goes. You know, it could, in a roundabout way, go copy some code, but let's go ahead and just go with it. I want to say while item is greater than self dot items, and then it's target index. So I start out at the first one. Is item greater than the first one? No. Is it? Target index plus equals 1. So that's that same stuff that we did before to walk our way through to find out where's this thing at? Where's it going to live, if you will? Now, when I find out where it's going to live, this one's not bigger than that one. I need to open a hole, if you will. I found out where it's going to go. That's the target index. That's where it's going to go. So this essentially kind of works like the remove, but backwards. So now we know where we're going to put it. Let's open a hole up. And we're going to say for I in range. Think about how we did this. Before we said target index to the end last one. Now we're going to go the other way around. then self, comma, target index minus 1, comma, minus 1. So, I'm going to deal with this the opposite way. We're going to start at the end and work our way back. And what are we going to do at the end? Well, I'm going to say, and this is as long as we have room. We check to see if we got room. All right. So now we're going to say, I'm running through this thing, self dot items I is going to get assigned the value of self dot items I minus 1. Oh, I got the wrong brace there. Essentially, I'm saying take what's at the end and move it out one more. Shift out, shift out, shift out. And we're going to do that until we get to target index. And then what is it that I want to do with that target index? Well, the target index, that's where I want to insert this new item and update the size. With self dot. And for this, let me back up. I need an underscore here. I need an underscore there. I need an underscore there. And I've got it here. It's a little difference because of how we're dealing with this thing. There, go there, and here. Okay. Looks like everything else we're still good on. Alright, we're getting our add cleaned up. Now, there we go, we've got that. Now, self underscore items. That's the one I want, not the other. And that target index is the one we're dealing with, equals item. Found out where it needed to go, and here's where I actually was able to put it where it needed to go. What else? Self dot size plus equals 1. So that took care of our add. Our add is sorted out. The only thing that we've got left, we got the add sorted. Let's doctor up this contains. And it'll be similar to a degree. Okay. Now, the contains, this is going to use divide and conquer logic, because divide and conquer we can use if it's sorted. This is sorted, so we can use divide and conquer. Divide and conquer is much faster, much more efficient than other search algorithms. So we're going to use that in this contains. We want to look and see if this contains something. So essentially we're going in and we're looking. We're doing a search algorithm. So I'm going to say left equals 0. Right equals the length of whatever it is we're dealing with self, and less 1, because programming, not algorithms. But we're using algorithmic logic now. Alright. So we're going to say while left is less than or equal to right. Now, I don't want to mess this up like I did a couple before. There we go. It'll come down. And what is it that I want to do? Well, I want to go halfway in between, which means find the midpoint. Let's divide. Left plus right divided by 2, whole number, non-fractional. So I found the halfway point. Round down if it's fractional. If self dot items midpoint. So if whatever's in the midpoint is what I'm looking for, man, wouldn't that be great? If that's what I'm looking for, return true. LF. Now, not there, I'm there. Self dot items midpoint, and same thing again. Self items midpoint is greater than item right equals midpoint minus 1. Else, hang on, let's back that up. Left equals midpoint plus 1. And there we go, return false. So this is that divide and conquer. We're going to work our way down until we find what it is we're looking for to see if it's in there. And all we're returning is a true or false. Either it's there or it's not. And every time we cut what we've got left in half, look to the right, look to the left. Which one are we heading to? Cut that one in half. To the right or the left. Which one? Cut it in half. Which one? And we're just cutting what we have left to search in half every time. So that's that divide and conquer logic coming from those search algorithms that I showed you in a previous module where I gave you those links. All right. So why we did this is excuse me, all about time complexity, being efficient. Now let's see what we've got. I haven't run this yet. This is from before. It had legacy. It says it doesn't like what I've done. So let's see what problem it's got. It says I've got a syntax error on line 116. And let me see. I'm in my add. Mutator. I do have an issue in here. Let's see what it is. I didn't hit return. That's not a complex error. Little things. So it still says it's got an issue. Array bag from line 19. Let's change it to sorted. And there's sorted. So they copied stuff over. They just wanted us to go clean it up for them. And I'm just dumping in the word sorted where it needed. Alright, let's see how we do now. And we're still not getting through them. I got through one more. It's got issue with contains it has a problem in contains. Let me go look. Well, let me go back and search. So we had the one issue that didn't insert the word sorted in the name. The other one took me a whole lot of doing to figure out what it was I did wrong. And it was a typo is all it is. Right here. This is empty method is a method which requires the parentheses there. That'll knock out these last two. And there it goes. Little things like that. All right. So we had to change things around because we were dealing with something that was sorted. So we had to deal with the add a little bit differently. And we had to check to see if there was already something there. And we did that with the divide and conquer algorithm. All right. So we'll see you in the next one. Save your files. We'll bring them forward.